All right, everybody. Today we're going to finish up on the two other parts from our notes yesterday. So if you take out your slope reference sheet, today we're going to talk about how to find slope from a table and how to find slope from 2 points. Um, so let me back up here. So let's start from a table. Okay. So it says find the constant rate. I'll tell you what. Let's do this. Let's make our pen a little skinnier here. That way you can actually see what I'm writing. And then write the slope as, just like the other day, with the from a graph, y over x. So let's say I give you a table. Here's your x value, here's your y value. I'll put some x values in here, and I'll put some y values in here. All right, so if you notice, let me use the green pen here. We'll kind of use the green pen to, so if I go from here to here, as you notice, every x value is increasing by 1. Right? So our x is 1. So we're going to put this, actually scroll this down just a little bit here. So underneath, so my y over x, my x is 1. And then I go down to my y's. My y's are every single time going by 2's. So my y is 2, which means 2 over 1 can be written as 2. My slope is 2. All right. So let me give you one that's a little, what happens when you have x doesn't go by 1's, because that's just a little trickier. All right. So if here's my x and here's my y, and let's say you get this. And your y, let's see here. How about this? And your y does this. All right. So if you notice your x column here, what are you noticing about every single value? From 3 to 6, from 3 to 9, from 9 to 12, I'm sorry, from 3 to 6, 6 to 9, 9 to 12, and 12 to 15. What do you notice? Yep. Everything is increasing by 3, right? So over here, our y over our x is 3. Now on the right side, what do you notice about these values? The y values are going up by 4. And since we can't reduce that anymore, our slope for that table is 4/3. So it's finding the constant rate of change for y, it's finding the constant rate of change for x, and finding the slope is y over x. All right, so that's finding for the points for a table. You'll be working on that today. And then don't forget too, you can also have a situation, what if I give you something like this? I'm going to erase the first one. You don't have to write this down. If you want to jot this in an open spot somewhere. What if I give you this? How would you find that slope? Well, think about this for a minute. The constant rate of change from here to here is 1 every time, right? So our x is 1. What's our constant rate of change for our y? What was that? There is none, right? It doesn't go up at all. It's 0. So 0 over 1 is 0. Our slope for that table is 0. Why? Because all the y points are the same. That means this is a horizontal line. If you have a table with all the x points are the same, you should know then the slope is undefined because it's a vertical line. All the x points are the same. So just a little tidbit on a side note so you don't get messed up with that. All right, so let's move on to the bottom right, which is finding slope from 2 points. All right, so you're going to label the x and y coordinates to start. And then it says find the change of y. So this is change. And the change of x by subtracting. Write the slope as the change of y over the change of x. Just like we have done in the past, right? So what you want to remember is you want to subtract the y's from the y's and then go in the same order with the x's. All right? Here's what that means. If I give you 2 points, if I give you -4, 7, and -6, -4, okay? So label your x and your y, right? That's your first step. So when you do this now, you're gonna use this little formula to plug it in. So depending on what one I start with first, let's say if I started with 7, so I'm going to do 7 minus a -4. So since I started here at 7, when I do my x's, I got to go in the same order. I got to start with -4. So -4 minus a -6. All right. So I subtracted 7 minus a -4, so I got to go from -4 to, I got to go the same order. Now I could have went the other way. If I started from -4 minus 7, I would just have to start with -6 for my x's. So I always got to start with the same coordinate for both x and y. And if you notice, the coordinates here are right over each other. Okay, there's the -4 on the bottom, 7's above it, and that was a coordinate. -6 is on the bottom, -4 is above it. So now I can go ahead and combine these. Well, when I got a double negative, this becomes positive, right? Both of them are positive. So 7 plus 4 is 11, and -4 plus 6 is -2. So my slope for this line is -11/2. Okay. I'm going to give you a few examples here. So number 2, we have 3, 0, and -11, -15. So again, mark your x and your y. Remember, x is always the first coordinate, y is the second one. All right. So if I start with 3, 0, I got to do the y first. So 0 minus -15. Okay. And then since I started with 0, my first x has got to be 3. So 3 minus -11. So now, again, I got double negatives. So I'm going to add 0 plus 15 is 15. 3 plus 11 is 14. I can't reduce that anymore. So 15/14 is the answer. Okay, just using that little formula. And I just got to remember I go in the same order every time. So let's give you one more. And then you can go ahead and start, we got to finish up our vertical lines, and then you can go ahead and you can start practicing. So 3, -20, and 5, 8. Okay, so again, label your x's and your y's for each one. So let's go the other way just to show you. So let's start with 8. So 8 minus -20. So since I start with 8, I got to start with 5 for my x's. 5 minus 3. Well, I got a double negative here, so 8 plus 20 is 28, and 5 minus 3 is 2. And 28 over 2 can reduce to 14 over 1. So your slope is 14 over 1 or 14. And that's your slope for that point. That's how you find the 2 points. So again, just making sure you keep going in the order that you started with. And your answers, again, it's just making sure you subtract correctly with your integers and working from there. Now, I did want to talk about one thing yesterday because some questions came up when we were trying to find the slope from an equation, okay? especially when they don't give you a really nice one. So I'm going to kind of, in your homework, you had problems that looked like this. Okay? And remember yesterday, you had to get it into that y equals mx plus b form. Okay? So just like this, I got to get the y on one side. So I want to take this 3x and move it over to here. And the only way I can do that is by subtracting 3x. I have to do its inverse. So when I do that, this goes away, and I'm left with 6y equals negative 3x plus 12. I can't add them together because they are not like terms. Okay, so if they are not like terms, I cannot add them together. All right. So now that I'm here, I have to get into y equals. Well, I got a 6y. So remember in solving equations, we had 2x equals 6 or something like that, and we had to move. We had to leave the x but move the 6. Well, now we divide. Since this is 6y and that's multiplication, we divide every term by 6. Okay, so 6 divided by 6 is 1, leaving me my y equals, which is what I needed. All right, negative 3 over 6x is basically negative 1/2 x. Or you can have negative x over 2. It's the same thing. And then 12 over 6 is 2. So now we got our equation and y equals mx plus b, right? Now you can tell me what the slope for this line is. It's negative 1/2. So hopefully that'll help you do some homework problems. Excuse me. All right. Our last thing we got to do is our last page. The video yesterday that's on the website went all the way through the first page of we got the vertical lines done. So if you missed the vertical line yesterday, you can go back and watch that video, which did all of page 3 in your reference notes, the horizontal and vertical exploration. So now we're on the back page. It says draw a line with the following conditions, then write the equation of the line. Well, if we're asking for a point, it says through negative 4, 7. So again, we have to remember that we start at 0, 0, and I'm going negative 4, so that's 4 to the left, and then 7 up. So that point should be right there. Okay? All right. I'm going to erase my 0, 0 point. And now it says, so the slope of negative 2. So if the slope is negative 2, that means I got negative 2 over 1, right? Which means I have to go down 2 over 1. So there's my second point. So if I go ahead and draw my line, if I draw my line straight through these points, whether you choose to use a ruler or not, it's strictly up to you. But there's my line through those 2 points. So that's how quickly I can draw my line with those conditions. All right. Well, then they said, look at the next one. Through negative 4, 7, so it's the same point, right? Right here. But now, what do you notice about the slope? It says undefined. What do you notice, or what do you remember what an undefined slope was? Who remembers what an undefined slope was? Correct, it's a vertical line. So, I'm going to take this line, and this should be going right up through. Remember, all the x values were the same on a vertical line. So that means my line is going through every x point of negative 4, and it goes to the point negative 4, 7. All right, and then the last one, again, same point again. But now I got a slope of 0. And what kind of line do you remember has a slope of 0? Right, horizontal line. So this goes across, and I'm just going to drag this up. Ooh. Let's try that again. All right, and there we go. So there's our horizontal line. It has a slope of 0 through the point negative 4, 7. All right, so let's talk about our summary. So horizontal lines are written in the equation y equals, and whatever the common y point is, that is our line, right? So if all the y points are 3, the equation is y equals 3. Our slope for a horizontal line is 0. Our slope for the y-intercept is 0. And then intercepts, okay? It has a y-intercept. That means it crosses the y-axis. And usually, most of the time, unless it's a different equation, which is a special case, but it has no x-intercept, okay? Vertical lines are in the x equals with the common x term that it would share. So like in the previous problem where we graphed those lines, and -4 was always our common point, x equals -4. Matter of fact, if I remember correctly, I don't think we even wrote those lines, did we? We did not. We forgot to write this part, didn't we? Equation of a line. So let's go back to that page real quick. So again, if I notice, when we write the equation of a line, it's y equals mx plus b, right? And b is our y-intercept and m is our slope. So if you look at the first one, our y-intercept, it crosses the origin, which means our y-intercept is 0. So we know our slope is -2. This equation should be y equals -2x. All right, if you go to the middle one, since we have an undefined slope, that equation is x equals, and all of our common points for x, which is -4. So our equation for this line is x equals -4. And then on the last one, the slope is 0, the horizontal line, it's always in the form y equals, and all of our common y points are right up here going across at 7. So our equation here would be y equals 7. All right, so if we turn back to the other page now, our slope for a vertical line is undefined. And it will have an x-intercept, but it does not have a y-intercept. So it has no y-intercept. And then last but not least, oblique lines. And you don't hear this word used very often, but an oblique line is a line that's diagonal. Okay? So obviously the equation is y equals mx plus b. The slope of an oblique line can be positive or negative. And these are lines that have both x and y intercepts. They will touch both lines or both axes at some point or another. All right. So those are important. They have both intercepts. So you can see the difference between the three lines. The diagonals are the oblique lines, the vertical and the horizontal. You can kind of see the pattern there. All right. So we've given you lots of information. So there is a little homework assignment for today, and plus the one you had yesterday. You got lots of class time to work on it. So you can use this hour to go ahead and continue it, and we will check this on Friday. Hope everyone has a good day.